For this problem, we are going to see an example of an angle of depression. And again, our key is going to be the picture. So let's go ahead and start with our word problem. A flagpole is 50 feet from a point on the ground. The angle of depression from the top of the flagpole to the same point on the ground is 40 degrees. Calculate the height of the flagpole to the nearest foot. Again, we draw a picture first. And this picture might be a little bit different than one we saw before, because we need to have a different kind of perception of what our line of sight is going to be. So we start with our flagpole, and we know that we have the ground. But where does our angle of depression go? Well, our flagpole here, our flag is going to be up here at the top. Its horizontal is going to go out like this. But we're told that it creates an angle of depression on the ground to a point on the ground right here. So just kind of imagine like the flagpole has eyes and is looking down at this point, and we're creating an angle right here. So we're going to use this angle to find this height. Again, we underlined the important information, and now we're going to put in some numbers here. So the first thing that I underlined was 50 feet from a point. We need to think about horizontal. If this flagpole is 50 feet from a point on the ground, we know that the point on the ground has to be 50 feet away from the pole. And the only way how a point on the ground can be away is if we think about the base of the flagpole. So here's our point right here. Then we have the angle of depression from the top of the flagpole to the ground is 40 degrees. Well, if my flagpole is right here, and the horizontal going out from the top of my flagpole is right here, and if the flag had eyes and was looking down to the same point of the ground, we would create an angle of depression right here of 40 degrees. Now we need, and then the height of the flagpole, we're just going to call it X. That's what we're wanting. We want to know what the height is. We want to know how tall. So here, I kind of want to talk about this picture for a second before we go any further. Actually, let's talk about it on this slide. Okay, what are we looking for? Are we looking for an angle, or are we looking for a side? Well, since we're wanting to know how tall the flagpole is, we're wanting to know a side. And what do we know about our angle? Well, we know a couple of things. But one thing I do want to point out is that this is a horizontal, and this is a horizontal. These lines right here are parallel. So the flag's line of sight out this way is the same as the ground. It's parallel to the ground. Well, when I'm given two parallels, and I have a shared side for two right triangles, this hypotenuse has suddenly become a transversal. And what do I know about alternate interior angles? I know that they are congruent. So I know that this angle right here has to be 40 degrees. Another way that we could solve this problem is to just find the height of this vertical line right here. It would be the same distance as the flagpole's length. So we could solve it either way. I like to use what I already know and go ahead and know that these are parallel lines and I have a transversal, so I can use alternate interior angles. However, we're going to get the same answer either way we do it. So what do we know about our angle? It's 40 degrees, and this is going to be our reference angle. So which trig ratio do we need? Well, regardless of whether or not I'm looking at it from this perspective or this perspective, I know that I'm going to go ahead and type in a 50 right here because I know that that's 50 feet because the distance from the flagpole to the point on the ground is 50 feet. So the distance that is taken on this horizontal has to be 50 feet as well. So either way, this 50 feet is helping make this angle of the 40 degrees. So this has to be my adjacent. And I'm just going to go ahead and put another X over here. And this has to be my opposite. So it would be opposite and adjacent. And if we look at this 40 degrees down here, we also see that the 50 feet helps make this angle. So it has to be the adjacent. And the x is the opposite. So we would have opposite and adjacent. Well, which of our trig ratios uses only the opposite and the adjacent? That would be, let me change my cursor here, that would be the tan function, okay? We have opposite over adjacent regardless of which angle that we use. So our equation is going to look like tan of 40 degrees is equal to the opposite x over 50 degrees, or over 50 feet, 50 feet. So let's just solve the equation. We have tan of 40 is equal to x over 50. Again, we cross multiply, but since x is in the numerator, we just can straight multiply 50 times the tan of 40 and get our answer. And that's going to give us 41.95 feet or 42 feet. Again, the angle of depression takes us a little step further. We have to decide how we want to solve it, which way we want to look. Do we want to look at our angle from here and know that this distance is the same as this distance? Or do we want to look at it by seeing that this is parallel to this, so I can use my 40 degrees because of alternate interior angles? Either way is fine. Either way you end up solving it 50 times the tan of 40. And either way you will get 42 feet.